Okay, in this video, I'm going to go over transformations, but a particular type of transformation. I'm going to go over something called a reflection. This is under Common Core State Standards for High School Geometry on Congruence, Standard A2. Now, in this particular video, I'm going to go over a couple of vocabulary words, line of reflection, mapping, and notation that might be helpful. Now, what I've done over here is I've set up a quick problem to demonstrate what a reflection is. Now, if you remember what a reflection is, it's taking an object, any kind of an object or a shape, and you are basically flipping it over or reflecting it across some kind of a line and producing a mirror image on the opposite side of whatever line you set up. Okay? Now, in this particular problem, I want to show you the technique that I use in order to make that reflection accurate. Now, this is what I do. Now, you kind of gathered what I mean by line of reflection, right? It's that particular line where the object flips over. Okay, it pivots right over the top. And normally in a problem like this, I have to produce what that line is or tell you what that line is. So let's say in this particular instance, I'm going to say that the line of reflection is where x is equal to 1. Now, what does x equal to 1 mean? And you'd have to remember some of your algebra at this point. Well, I know that this is the x-axis, right? This is the y-axis. I also happen to know where x is 1 is right here. That's one of the spots. And you're thinking to yourself, well, that's not a line. What about where the rest of it is? But notice that x is also 1 here, right? It's just 1, 1. X is also 1 here. It's 1, negative 1. X is also 1 here. It's 1 on the x, negative 2. In other words, it doesn't make any difference what the y is as long as the x is 1. And this is producing the line of reflection, okay? So this is the line that this particular figure is going to reflect over. Now, this is what I do for this kind of technique. You'll notice that, and let me just make this a little bit bigger and move it off to the side here. In this instance, what I have done is I have identified what each of the vertices of my figure is. And that's a really good first step for you to do, right? So 1, identify vertices of the figure that you're using, okay? Or if it's a circle or something like that, you have to identify some really important point in this circle, like maybe the center of the circle. But anyway, we're dealing with a triangle here. And you'll notice that it's negative 1, 0 is one of the points. What I ask myself is, how far away is that vertex from the line of reflection? Along the x-axis now, right? Because that's how far away I'm going here. And I'll notice that it's actually 2 points or 2 units away, which means that my reflected point has to be 2 units on this opposite side. And the y-axis is not changing. The y is still staying along the y. So there's my first point. Now, what you'll see in a lot of these problems is that the pre-image, the blue, right, is always done in the blue triangle, rather, is always done in blue, and the post-image, or the image, rather, itself, is always done in red. So I'm going to do the exact same thing. So the vertex here is going to be 1, 2, 3, 0. Let's do the same thing with this top one. This top x is 1, 2, 3, 4 units away from the line of reflection, which means it has to be 4 units further along this direction. So it's going to be 1, 2, 3, 4. And let me see, 1, 2, 3. So it'd be 4. And again, the y would stay the same, 4, 2. Down here, we already know that that's 4, and it's 4, negative 2. Let's draw what that new reflected figure is going to look like. So there's 1, 2, 3. 2 further units, make that a 5. I'm sorry, because it had to be 4 units away from where x is equal to 1, right? So that's going to make it 5. So 1, 2, 3, 4, 5. And then 1, 2, which would be right up there. And the same thing here would be 1, 2, 3, 4, 5, down to there. And there is my reflected figure. And you can see how that would work, right? I would just take that figure and then pop it right over to here, and there's the reflected angle. Now notice I made a mistake here, and it's a really common mistake that a lot of people do. I counted over 3 plus 1, which is 4 units, and instead I started from here and counted over 4 originally, and that's just wrong, because this is now like my new 0 point, if you want to call it that. The line of reflection is, all right? So 4 away from 1 would be 5, and that's why that vertex here is 5, 2, and that's 5, negative 2. Now, I'm going to try to give you a problem of your own to solve. Here it is. And here's the question. Transform this figure by reflecting it across the following line. X is equal to negative 2. So identify where x is negative 2. There it is. It's also negative 2 there, 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 there. There's my x is negative 2. Okay? Now, go ahead and, like I said, identify the vertices rather. Count how far away they are from the line of reflection. And I'm going to let you do that. Take a second right now. I'm going to shut this down for just a second. Stop the video right now and see if you can come up with the correct answer, okay? All right. I'm assuming you're back now. I notice that negative 5 is 1, 2, 3 away from the line of reflection, which means I'm going to go 3 to this side. 1, 2, 3. And I'm going to stay right there, okay, because it's straight across. Negative 8 is 1, 2, 3, 4, 5, 6 away from the line of reflection. 1, 2, 3, 4, 5, 6, and then down 2. Same thing with this one. It's over 6 from the line of reflection, which is right here, and it's down 4. 1, 2, 3, 4. So right there. When I go ahead and map, this is called mapping, by the way. It's when I actually move this over to here, all right? And I'm using this particular symbol. Now, the notation that I use are these particular arrows. If I wanted to call this point A, this point B, this point C, the new notation would be A1 would be this point right here. A sub 2, or A superscript 2, would be here. Sorry, I needed it to be 1 there. And this would be C1 here. That just means that I've just moved it over to a new location, okay? I don't know why I put 2 there. Let's make it correct. Now, as a further test, I would like you to see if you can identify what these vertices are and see if they match up. Okay? Good luck.